Inverse of a matrix. We haven't talked about the whole algorithm and the use of inverse of a matrix, but we did have a discussion about what is inverse of a matrix. So let's say you have a square matrix A, right, of order n, and if there exists another square matrix B of or same order, right, such that the product of A with B or B with A, so you write it either AB or write it BA, the overall product is identity matrix, right? So if for any square matrix, let's say this is a matrix A, right? If we can find out another matrix B, which satisfies this condition, A into B or B into A is equals to identity matrix. And if you forgot about identity matrix, I would like to revise that again, because identity matrix will be very important going forward during this whole conversation of inverse of a matrix. So identity matrix is a matrix in which all the diagonal elements are 1, right? And all the non-diagonal elements are 0. So for example, I take a 2 cross 2 matrix. Now, from here on, whenever I use the word matrix, I will mean this square, I will mean that matrix to be square, right? So we need not to revise it every time. So I take a matrix and its order is 2. So the identity matrix will be 1, 1. These are the diagonal elements, and other than diagonal elements, all the elements will be 0. So we can write this as I2. We can simply write it as I2. I2 will be identity matrix of order 2. So similarly, if I write I3, these will be the diagonal elements, right? And all the other non-diagonal elements are 1, 0, 0, 0, 1, 0, 0, 0, 1. This is how it goes, right? I2 and I3. So whenever we find for any square matrix A, if we find out another square matrix B by taking the product of which in either form, either AB or BA, we get an identity matrix, then A and B are said to be the inverse of each other. So B is the inverse of A. So I can write B as A inverse. Now how do we write inverse? We just put a power -1. We don't read it as A to the power -1. We read it as A inverse. Inverse has a different function here, right? But mathematically, you can see that if you write A to the power -1, that can be written as 1 by A. Hello, Madhya.
Hello, sir.
Where were you in the last 2, 3? I guess you missed 2 classes.
Yes, sir. So because I had my test going on, so I was preparing for that.
Okay. So we are talking about inverse of a matrix. So a adjoint of a matrix, basically. We are in the last phase of determinants. This is the new syllabus, first of all. We haven't had this syllabus in the past 6, 7 years, or in fact, 10 to 15 years. This was not in the syllabus with the portion which we are studying now. So yeah, this portion was in the syllabus, but not the Kramer's rule and system of how to solve system of linear equations. So I guess you have already studied determinants. Am I correct?
Yes, sir.
Okay, okay. Is equals to identity matrix, then they are said to be the inverse of each other. Now, I can write B as A to the power -1, but it will not be read as A to the power -1. It will always be read as A inverse, right? And similarly, I can write B here as B inverse. This is B inverse, right? Okay, so now whenever I see a square matrix, there will be two questions. There should be 2 questions in my mind. First is whether its inverse exists or not. I mean, it may be possible that for any square matrix A, there is no such matrix B that their product is I. It may be possible, right? So the first question is whether its inverse exists or not. And second question is, if its inverse exists, how do we find that inverse, right? So there are 2 methods which we have discussed. I mean, we haven't discussed the methods, but we did discuss that how to find out the inverse of a matrix. So there are 2 methods. First method is elementary operations or transformations of a matrix, which used to be in our syllabus prior to this year. Okay? But now this is reduced and this particular topic has been eliminated. So we have another method to find out. Okay, we haven't discussed it yet. So we have second method to find out the inverse of a matrix, right? Now, I'm just writing the basic of it. Here, we will cover it in the determinants only. So I'm writing the second method or second approach is to find adjoint. Oh, sorry. Inverse using adjoint, which is actually a better method and much easier to calculate inverse using adjoint rather than going for elementary operations. So we will find out inverse using adjoint, and it uses a simple formula, right? So if you want to find out A inverse, let's say you have some matrix. Consider a square matrix A, then its inverse exists if, first of all, when does the inverse of any square matrix exist? So you have to find out the determinant of that matrix. If the determinant of that matrix is not equal to 0, means that the determinant value is non-zero, then only inverse exists. And if its inverse exists, the formula to find out its inverse is, so A inverse is equals to adjoint of A divided by determinant of A. Now you can easily remember this. When will our inverse exist for any square matrix? Whenever this denominator is non-zero. So let's say if this is 0, A inverse becomes not defined, right? So this should be non-zero for existence of inverse. Should be non-zero for the existence of inverse, right? And this is adjoint of A. Now the task will be how to find adjoint of A. So we will discuss this in details in our ongoing chapter, right? So, and also we have one proof, very easy proof of this, that if inverse exists for a square matrix, then it will be unique. What does it mean? That you will have only and only one matrix B for the matrix A, such that this condition happens that AB is equals to B, A is equals to I. You will not get, if for A you get a matrix B, which is its inverse, then there will not be another matrix C, which will be the inverse of A. So inverse, if exist, will be unique. Inverse, if exist, will be unique. And this is a very important proof because they have given this in the syllabus that just a minute. I think we don't have to. Yeah, so I'll write it because they have given this in the syllabus. So it may happen that they can ask this proof from this matrix. That is why we need to show it. Just 1 minute, guys. Although I'm sure about the syllabus, but let me check it once again. Yeah, invertible matrices. matrices and proof of the uniqueness of inverse if it exists. Correct. So we'll have to cover this. And it is a very simple proof, by the way. 4-liner proof. So it says that proof is for uniqueness of inverse. So it says that inverse of a matrix if it exists is unique. So what we are saying is that consider any matrix A, or rather consider any square matrix A, and let's say the order of this matrix is n, right? So A is a matrix. Let's say this is our matrix A, whose order is n cross n. It is a square matrix, so it is given as order n, means that n cross n order is there for the square matrix A. And we have to prove that this will not be the condition, that if AB is equals to BA is equals to I, what does that mean? That A and B are inverse of each other? So we have found the inverse of A as B, right? So B is the inverse matrix for A here. Now we are saying that there is another matrix C as well. There is another matrix C as well, who gives the same result, that AC is equals to CA is equals to I. First of all, this will not be possible. This is not possible. So what are we trying to show? That if this is possible, then it means that they are same matrix, B and C. They are not different. No. So for any matrix, there will be only and only one inverse matrix which exists. And we want to show that if any such condition arises, that if you are saying that AB and AC both gives both gives I, then we are saying that B and C should be equal. They are not different. No. So this is the proof of, this we have to show. Now, how we are showing? Just a minute. Oh, Anisha, you're late in the class, but I think you have already studied determinants, so it won't make much difference. Yeah. So what we are saying is that if, let's say, B is the, now you take it as B is the, you consider that B is the inverse of A. This is just to show you. This is not the part of the proof. This is for your understanding. And this is not the part of the proof. The proof starts from here, right? So we are saying that consider any square matrix A of order n. So let's say A is like this. Okay. Now let's take, we are trying to show it by contradiction. So there are a lot of proofs in maths which goes by contradiction. Contradiction means that we are assume that there are two possible, matrices, two possible inverse matrices exist for A. And these matrices are B and C. So we are assuming that there are two inverse matrices which are possible for our matrix A. And we have to show that if there are two possible inverse matrices for A, then they have to be equal. That is B is equals to C. So just This is just for your understanding. Okay, so we are saying that since B is the inverse of A, so we know that what is the result for inverse. If B is inverse of A, then we can say that AB or BA is equals to I. We are just simply using the result of inverse. We first assume that there are two possible inverse matrices for A, and we are naming them B and C. And then we are using simply the result of B and C. I mean, the result of inverse. And C is also the inverse of A. So it means that AC is equals to CA is equals to I. Okay. Now, from this, we are saying, let's start it from here only. So we can write it just. Okay. So we know these two results, that AB is equals to BA is equals to I, because A and B are inverse of each other. And we are also saying that A and C are inverse of each other. So AC is equals to CA is equals to I, right? Now we are starting from here, that we can write B as B into I, because I is just like 1. I've already told you. If you multiply I with someone, it is the same matrix. So we can write B as B into I. And we can write I.
Sir, what is I?
I is identity matrix. I's are identity matrix. So this is the basic definition of. Have you heard about inverse, like the definition of inverse, Travis?
Yes, yes.
Yeah, so that is the same I. If there are two possible matrices, the product of which becomes identity matrix, then they are said to be the inverse of each other. So this I is basically for identity matrix, right? So, and there is a property related to identity matrix that you can multiply it with any other matrix and it gives you the same matrix, right? It just behaves like 1. The arithmetic number 1, as in all the arithmetic calculations, 1 behaves. This behaves the same in matrices. So I is just like 1. You can write B as B into I. Now use this result of I.
Sir, if you are
Yes.
multiplying B into I, so B same, we will get same matrix.
Yes. I is that there is a property related to identity matrix that if you multiply it with any other matrix, so A into I is equals to A. You multiply it with B,
Okay.
any matrix, this results the same. Just like 1. 5 into 1 is 5. Similarly. Okay. So we are actually introducing, we want to introduce A and C here. Now, why? You will get it easily, because I want to use B into A. So instead of A, I use the second result. I'm naming these results as 1 and 2. Using 2, I can write B into I as B into A into C. And we can combine B into A first and then C. Then B into A from first, B into A is equals to I. Now I into C is again C. So B is actually equal to C. If there is any scenario in which we are taking two different matrices, then we are assuming it wrong. Actually, they are not two different matrices, they are the same matrices. So we can easily show this using the simple algebra of matrices, using the property of identity matrix and using the property of inverse, both of which are given. So assume any two different inverse matrices, then use the result AB, BA is equals to I and AC, CA is equals to I, because they both are inverse, right? And you know, you can multiply identity matrix with anything. So you are just taking B, writing B as B into I, because you can write that. And by introducing I, you have introduced A into C from the second equation. Now combine B into A first. B into A gives you I into C again gives C. So actually B is equals to C. You started with B and ended up on C. So you can say, hence, B and C are not two different matrices, or you can easily say that hence B and C are the same matrices which is also an inverse for A. So inverse, if exists, will always be unique. And how do we know if it exists or not? You have to first find out the determinant of that matrix. If the determinant is 0, don't go again. I mean, don't go forward. Just write that inverse of this matrix does not exist. Right? And if the inverse is non-zero, then we will have to find out the, I mean, if the determinant is non-zero, then we will have to find out the inverse. And to find inverse, we need this. Which is adjoint of a matrix. So adjoint actually solves out a lot of things in matrix. But before understanding adjoint, we needed to understand cofactors and the value of a matrix. So basically the value of a matrix is like determinant of a matrix. So we need to know two things, cofactors and the determinant of a matrix. So let's start it with this. We have a matrix. Also, before going for adjoint, I would like to write again about the inverse. Inverse using adjoint. Inverse using adjoint can be done as for any square matrix A, A inverse is equals to adjoint of A divided by determinant of A. Determinant of A has to be non-zero. Existence of A inverse. Right. Now, there's a very, first of all, there's a technical term associated to it. Let's say you find out for, I would like to write it here. So this is for any square matrix A. If determinant of A is equals to 0, it is called, A is called singular matrix. So all the matrices, or rather all the square matrices whose determinant is 0, or whose determinants are 0, are called singular matrices. And we don't find out the inverse of a singular matrix, because the inverse of a singular matrix does not exist. Right? So inverse of a square matrix exists if it is non-singular. So first you check this out for me. Check all these, whether they are singular or non-singular. Yes, what about the first one? Singular, non-singular. Yes, please.
Non-singular.
Singular.
Non-singular, right? Determinant of A in this case must be -2. Yes, second,
Singular.
singular. Okay. I don't think so. No. Austin, what did you get? Is it singular or non-singular?
I got non-singular.
Non-singular. Okay. What's the value of determinant?
20.
I'm sorry.
20.
20. Okay. Is it correct, Chavez? Determinant of B is 20.
Yes, sir.
Is the determinant for matrix B is 20? Is it correct?
Yes. Sir, I have to solve.
Please solve. That is what I want to.
Two sir, I have to solve.
Madhya, determinant what? What did you get? Value for determinant B.
So I'm doing so.
Mamuddin, Faiza,
So for V, I got a singular matrix somehow.
you got a singular matrix, right? Okay. And Iram, what about Mamuddin?
One minute.
Kharif? Okay, first of all, please start solving it very quickly because in
Sir, is it
adjoint
80?
18, yeah, correct. So you have to find out the value for determinant quickly because we, this is a question, this is a certain question. Okay. I mean, this has to come for 5 marks or 6 marks. It used to be for 6 marks before. I mean, the question from matrices and determinants, one question will be from 6 marks, but I don't know the highest marks for now. But whatever is the highest mark, this will be the question to solve. This is a certain question. You have to find the adjoint, you have to find the system, you have to solve a system of equation using the inverse of the matrix.
Sir, C is 0, right?
C0. I don't know. Someone has to confirm it.
So I
But
got
whoever
0.
is not, yeah, Faisal, C0.
Yes, sir.
Okay. So whoever is not solving, whoever is not finding out the determinant for these matrices, please start solving it because I mean, without this, you will not be able to find the adjoint. And for adjoint also, you need to calculate a lot. So start working on your calculation. You will get it why I'm saying this. Just let me come to this adjoint of a matrix once. So this is a singular matrix here, and these two are non-singular matrices. So we can find out the inverse for these matrices, right? Now to find out the inverse, we need to find this adjoint. So first understand what do we mean by adjoint of a matrix? So we are given a matrix. How do we find its adjoint? It's a very simple formula again. Simple looking formula, but very tough to calculate. There's a high chance that we will mess it up. So consider any square matrix A, and I'm taking both of them. Consider a square matrix A, or rather, we have two kind of square matrices only. One is order 2 and one is order 3. Order 2 is pretty easy, order 3 will be tough. So I'm taking both of them and trying to find out the adjoint of their matrices. Okay, understand it using the example. Consider a square matrix A which is of order 2, right? So I'm writing it as A11, this is as A12, then this as A21, or rather than A11 and this, I'm also using the simple terms A1, A2 and B1, B2, okay? This would be simpler to use. A1, A2 and B1, B2, we know that the order is 2. Now to find out its inverse, okay, sorry, my bad. First of all, I would like to write it for a general order. So let's start it from here. So we have this square matrix A1, A2, B1, B2, right? Then its adjoint will be defined as, every adjoint will be defined in the similar way. Adjoint of A will be the transpose of, we know about transpose, right? Okay, we'll revise the concept very easy. So transpose of, find out the cofactors for each element. So I'm writing the cofactor of A1 as capital A1, capital A2, then capital B1 and capital B2. So this inverse, I mean the transpose. Now the transpose of any matrix is given as, if you interchange rows and columns. So there are 2 rows, A1, A2 and B1, B2. I'll make them columns. So the first row A1, A2 will be the first column now. And then second row B1, B2 will be the second column now. This is the adjoint of it. Now what are these capital A1, capital A2, capital B1 and capital B2? So these are cofactors. So B1 and B2 represents, are the cofactors of element A1, A2, B1 and B2 respectively. So you find out cofactors for each element, right? You find out cofactor for A1, small a1. You find out cofactor for small a2, then small b1 and small b2. You place those values at their respective places and then take the transpose of this matrix. In that way, you will get the adjoint of matrix A. Now let's find out. We have the values. In terms of these values only, let's find out the adjoint. So I will try to revise you the concept of cofactors again. So I don't know why you guys are not calculating determinants every time I ask you, but please try to understand it again. So the value of a determinant will be determined only after we calculate cofactors, right? So cofactor for any element was, we know the minor for any element, Mij, for element Aij. Okay, rather than writing this, I'm just going to the concept in this. Yes, we have already discussed the concept of minor of an element and cofactors of an element. So let's say you have some matrix A, this is a square matrix, right? A, and we want to find out the minor. So minor exists for each element, first of all. Now, what is a minor? If I want to find out the minor of, let's say, this element, A32, I have already trying to find out, I showed here. So for A32, if I want to find out the minor, I will delete its column. I will delete its column and I will delete its row. Right. whatever left, that is A11, A13, A21 and A23, that is the minor of this element A32. So if I want to find out the minor for first row, first column element, so I have tried to find out minor of element A11, right? M11 is the minor of element A11. Now M11 will be delete the first row and delete the first column. Delete this, whatever is written here, delete this. Delete this. If I want to find out M32, I will delete third row and second column, right? And whatever left, the determinant of that value is the minor of this element, right? So Mij can be obtained by deleting ith row and jth column from the matrix. That is how we find out the minor for any element. And the cofactor was a simple explanation. Cofactor was -1 to the power I plus j into Mij. So whatever is the value for minor, cofactor will be either the same value or its negative time. Either the same value or its negative times. How do we know? Just the sum of I plus j will tell us. If the sum of I plus j is odd, cofactor will be minus times of minor. If the sum of I plus j is even, the cofactor will be same as minor, right? And I have also given you some examples to calculate these minors and cofactors, but we will understand it again when we find out the adjoint, how to find out the cofactor for any element, right? So let's say we are trying to find out the cofactor for this, okay? So cofactor of A1, small a1 is capital A1. Now, how do I find cofactor? This is the element from first row. This is the element from first row and first column. So I here is 1 and j is also 1. So I will write it as -1 to the power 1 plus 1, because this element belongs to first row, first column, right? Into minor of it. Now, how to find out the minor? Delete its row. So delete this and delete this. What are you left with? B2, only B2. So right here, B2. Right, B2 here. So A1 will be -1 to the power 2, which is positive. So this becomes B2 only. Now I'm trying to find A2. A2 will be, if I delete its row and its column. So A2 row will be this and A2 column will be this. Delete both of them and write -1 to the power. First of all, write its row, which is 1, plus its column, which is 2. And whatever you are left with, B1, which is -B1. Again, capital B1. I'm trying to find out capital B1. So capital B1 will be, can someone suggest me how to find out capital B1? Which row and which column I have to delete? Can Tharif tell me which row and which column I have to delete if I want to find capital B1?
Sir, second row and
Sorry, I'm not able to hear you, Tharif. Please speak loudly.
sir, can you hear now?
Yeah.
Sir, second column and first row, or second column and second row?
No, sorry. We are trying to find out B1.
Oh,
Yes, B1 is the cofactor of small b1.
so then it could be a second row, second column, first column.
Second row and first column. No, this belongs to this column.
Yes, sir.
Yeah, so first column and second row. We have to delete first column and second row to find out the minor of this. And to find out the cofactor, we will just apply this -1 to the power wala formula as well. So -1 to the power, this belongs to second row and first column. And the value left is A2 in this case. Delete this and delete this. So value left is A2. So this will be minus times of A2. Okay. Humamuddin, can you tell me how to find out B2? Tell me the complete expression.
-1 to the power of 3 plus 1.
Sorry, 3 plus 1.
Oh, 3 plus 2, sorry.
Do we have 3 rows or 3 columns here?
No, sir. So,
Maximum number of rows or maximum number of columns can be 2 only, no?
yeah, yes, sorry.
So it should be
2 plus 2.
2 plus 2, correct. Second row and second column. And
Into
delete its row and delete the column. I mean, whatever for whatever element you are finding out the cofactor. You're finding out B2, capital B2, which is for small b2. A1, right?
yes.
So this should be A1. Now, if I'm trying to find out adjoint, I have all the values for cofactors. So adjoint of A in this case will be what? Transpose of B1 minus B1, then minus A2 and A1 and its transpose, which I can write like this. I could have written it directly as well, but because we are solving the first question only, or we are not even solving the question. We are just trying to find out or just trying to understand the concept. So that is why I will write it in every step. So adjoint of A in this case will be B1 minus A2 minus B1 A2, I mean A1, and its inverse exists. Inverse of A exists, rather we should write it like this. So we know what is the adjoint of A. Now, A inverse exists if determinant of A is not equal to 0. So we can find out the determinant for A, but to find out the adjoint, there is a very simple formula for 2 cross 2. I mean 2 cross 2, there is a shortcut. But for 3 cross 3, you will have to go through whole to find out all these elements, or I mean all these cofactors, and then apply this formula. This is the main formula. This. Using this formula, you can find out the adjoint for everyone. But for 2 cross 2, it is rather simple. So let's start with the initial matrix A. Initial matrix was A1, A2, B1, B2, right? Now observe the adjoint. What is the adjoint matrix? Adjoint matrix, final matrix, is this B1, A1, right? Sorry, my bad. I think this was B2, first of all. I've written it wrong. This was B2, so this has to be B2. Yeah, so the final answer is this was A1, A2, B1, B2. Observe that these two values hasn't changed. Rather, they have been only multiplied with -1. They have been multiplied by -1, and these two diagonal elements got interchanged. Right? So for 2 cross 2, very simple shortcut to find out the adjoint. Okay, just change the diagonal elements and multiply the non-diagonal elements by -1. Change the diagonal, interchange the diagonal elements and multiply the non-diagonal elements by -1. This is the simple shortcut for finding out the adjoint of a 2 cross 2 matrix. Yes, so this is a shortcut for 2 cross 2. For 2 cross 2 square matrices, to find out the adjoint, follow 2 steps. First step is interchange the diagonal elements. And second step is multiply the known diagonal elements by -1. Now, I do know the whole procedure, but rather than going for the whole procedure, I would directly go to this because this is pretty easy. For 3 cross 3, I will have to anyway go through the whole process. But for 2 cross 2, I would not like to go. So let's find out the inverse. I mean, let's find out the adjoint for this 2 cross 2 matrix. We have been given this 2 cross 4, 7, 2, 3, right? For example, 1. Right, this was the matrix. Now I can write this adjoint directly. Adjoint of A will be just interchange the diagonal matrix. So this would be 3, this would be 4, first step. And then multiply the known diagonal elements by -1. This would be its adjoint. You can find that out through the whole process, but this will remain the same. This will not change. Right? So for 2 cross 2, the find 2 cross 2, the finding to find the adjoint, we just have to follow these 2 steps, which is easy. But now let's find out the adjoint for a 3 cross 3 matrix. But before that, for a general square matrix of order n, so we are basically saying that A is a square matrix whose element is Aij and the order is n cross n. Its adjoint can be written as its adjoint will be just take the cofactor for each element. Just take the cofactor for each element and take the transpose, whole transpose. So where Cij cofactor of Aij. This is the formula for adjoint. A pretty simple formula, but there is a lot of chance that we will be finding this out incorrect. Now let's find out the adjoint for a 3 cross 3 matrix. First with me, then second you will try to find out on your own. So find the adjoint of given matrices. Now I am extending the question and also inverse if it exists. So first we'll find out the adjoint because we will have to find out adjoint anyway, right? But after finding out adjoint, we will also check whether its inverse exists or not. If it exists, we will find out the inverse. Okay, first part is A is equals to 1, 2, 3, -1, -2, 4, and then 0, 3, 0. So let's find out the inverse, I mean, adjoint for this first of all. So we know how can we write adjoint. So to write adjoint, first of all, we will tell the formula for adjoint of A, which is Cij transpose n cross n, where Cij is cofactor of the element which belongs to ith row and jth column. So basically, we will have to find out the cofactor for each element here. We'll first find out cofactor for 1, then 2, then 3, -1, -2, 4, 0, 3, 0. And after that, we will use the given formula to find out inverse. To find out adjoint. So I would like to ask you guys, first tell me the cofactor for 1. Everyone, don't tell me directly, text me. I'm waiting for everyone. I just want you to find out one cofactor. Cofactor for this value. Only one. Only for this element.
-12.
Correct. Okay, Shavis, you don't have to tell me that. I just want to check whether everyone is able to find out the cofactor or not. So please, you have spoiled my mission. But again, please find out for this 2. And text me. Don't tell me. Text me. Which who answered me? Austin. Yeah, Austin, you were correct. So please find out all the cofactors. I will also do this. You have to do, you start doing it, then I'll start. I will also start solving it. Everybody has to check because there's a high possibility that we can solve it incorrectly because we have to find out 9 calculations. It won't be so easy. I'm especially interested from Humamuddin and Faiza because Iram and Tharif. Rest I am assured about that you can find out. Iram, Humamuddin, and Tharif. All 3 of you. Please tell me the cofactor for 2. Austin, you are again correct. Pfizer is correct as well. Humamuddin and Tharif, can you find out the cofactor for this element 2? If not, then please tell me. I will help you out. No worries. To find out the cofactor, use the formula of minor. Okay, cool. It's okay. It's okay. And what about Tharif? Okay. Chalo, let's find this out. Yeah, so let's find out some of the cofactors with me. We'll check this with this. Just a minute. Yeah, also. Yeah, so see, they have given this question and this is matrix A, for which they have to prove this something, they have to verify something, but don't focus on that. Just focus on that. How are they finding adjoint of it, right? So for 1, okay, they haven't shown here. Okay, cool. I'll show you. Aram, are you able to find out the cofactor? If not, then just reply me on text or however you are comfortable or not. So let's learn with me. Okay. So we are trying to find out the cofactor. So this is the first row, first column element. This is first row, second column element, right? You should know the row and column for each element, right? You are comfortable with that or not? 4. second row, third column, right? You have to first check horizontal order, then vertical order. Okay. I mean, horizontal order माने ये, and vertical order माने ये कहाँ पे? Column कौन सा है? First check the row and then check the column. So second row, third column. This is important to know because we have to use the formula for -1 to the power I plus j. You know? Okay. So for cofactor, let's take this element. So this is C11. I am finding out C11. C11 means cofactor of first row, first column element. So which is 1. So we have to find out the cofactor for this. Delete this. Delete this. We are left with -2430. You have to take the determinant of this using this formula, -1 to the power I plus j. Now I here is 1 and j is also 1. Because this element belongs to first row and first column. So you can take I and j as 1. Now after this, take this whole determinant, which is -2430. This is the value of cofactor 1, 1. Mane cofactor of first row and first column element. If I want to find out C12, first of all, which cofactor I am talking about? I am talking about cofactor of which element? Can you tell me this? One.
So 2, right?
2, yeah, correct. So we are talking about this element 2, first row and second column element. We will delete this and we will delete its row to find out the cofactor for 2. And which will be -1 to the power 1 plus 2 this time, because first row and second column, into determinant of whatever left, -1400. Now this value, -1 to the power 2 will be plus, and this would be -2 into 0. So this is +1 into this internal value will be this. That is how we solve. Just cross multiply and take negative. I mean, cross multiply and subtract. This will be the value of this 2 cross 2 determinant. And hence the answer will be -12 here, because this is 0. 0 minus 12 is -12 into 1 is -12. Then again, this one, -1 to the power 3 will be -1 into, to solve this, -1 into 0, -4 into 0, which is 0. Humanuddin, Tharif, Iram, did you understand this?
Yes, sir.
What about Iram and Tharif?
Yes, I understood.
Hello, Iram. You have to find these out now for all 9. I'm also finding out. Let's try to solve them on their own. Everyone try to solve.
So can I say?
Yes.
So cofactor for C13, it will be +3.
No, that is wrong.
Yeah, so
It should be -3.
so it will be +3 because okay, sorry, yeah, it will be plus. It will be -3, yeah. Sorry. My bad.
So C2.
Then for 821, it will be +9.
Yeah, correct.
Then for 822, it will be 0.
Yeah, just call it C22.
Oh yeah, sorry. C22, it will be 0.
Correct.
Then C23, it will be -3.
Yes.
Then C31, it will be 14.
Correct.
Then C32, it will be -7.
Correct.
And then C33, it will be 0.
Yes. Correct. Good. Really good. So the important task is to calculate all of these cofactors correctly. Now, please, everybody check these. especially Mahmoudin and Tariq, and also Faisal, Austin. Only Madhya and Chavez has been doing this consistently, correctly. So you guys also try to solve these. These should be the values. Please compare it. And if you have any doubt, feel free to ask. This is going to be really important for us, guys. We have to find the adjoint. This is a certain question, 100% probability. I am telling you, sure event. In terms of sheer probability, this is a sure event that this question is going to, they are going to ask this question that solve the system of linear equations. And to solve that system of linear equation, you need to find the inverse. The difficult part is to find the inverse only. Solve that equation using inverse is the actually easier part. But you will not be able to find the inverse correctly. I have been doing this for many years and I have been telling people, I have myself done this mistake. So this is not easy to calculate. And I mean, the formula is simple, but the calculation is not. Okay, so now we have all the cofactors. So the adjoint, yes.
C1 is -9.
Which one? C21. Okay, just. C21 should be -1. I mean, we are finding out to -1. Okay, so -1 would be, that's okay. So -1, delete this and delete this. This would be 2 into 0 minus 3 into 3. But as the element is from second row and first column, so C21 should be -1 to the power 2 plus 1 as well. No? Yeah, so as we have all the cofactors now, so we can easily arrange these cofactors at first of all at their respective positions. So this will be -12, then this will be 0, then this will be -3. Then this will be 9, 0, -3. Then this will be 14, -7, and 0. Cut transpose. All of this transpose, right? So first of all, place all the cofactors at their respective elements position and then take the transpose. So this will be -12, 0, -3. First row will become first column. Second row, 903 will become second column. And then 14, -7, and 0 will become third column. So this will be the adjoint of A matrix. Guys, did you get it? Please feel free to ask your problems. I have done this once. I will do this again because what I want to show you is that how to write it directly. So take all the first column, take all the first row cofactors. This is C11, C12, C13. One is constant here. C11, C12, C13 means that all the first row cofactors. Take all the first row cofactors and write them in a column directly. So -12, 0, -3. Then these three, 9, 0, -3. And then these three, 14, -7, 0. That is how you can use these cofactors to write adjoint directly. Don't go every time for transpose. Write the cofactors of rows in a column. And that way you can maybe save your 30-40 seconds. But if you are not comfortable, then don't go for it. Don't worry. These 30-40 seconds will not matter much, I would say. But try to solve it correctly. Okay. Now, after this, we will find out. After this, we will find out the inverse of it. Now we also have some properties based on this inverse and adjoint, but rather than properties, I would again focus on finding out the inverse and adjoint correctly. We will have to cover these properties as well. This one, no, -12.
Yeah.
C11, the cofactor of first row and first column.
Okay.
Element. Yeah. So after this, I will try to find out determinant of A. Now, determinant of A, I know I can expand it along any row or any column. Also, I have all the cofactors. See, I have all the cofactors, so I can very easily write out the determinant. So 1 into cofactor of first element, which would be -12. I'm expanding it along the first row. 1, 2, 3. Okay. So 1 into its cofactor -12 plus 2 into its cofactor, which is 0, plus 3 into its cofactor, which is -3. You can check these cofactors for first row. So I'm just multiplying every element to its cofactor and taking the sum of it. That would be the value for determinant for any row or any column. This should be -12, -9, -21, which is not equal to 0. Hence, A is non-singular. If A is non-singular, I can easily find out its inverse, because I already have adjoint and the value of the determinant. So A inverse exists in this case, or inverse of A exists in this case, and A inverse would be adjoint of A divided by determinant of A. Determinant of A is 1 by -21, and adjoint of A is -12, 9, 14, 0, 0, -7, and then -3, -3, and 0. You can take this -21 inside. This will become 12 by 21, which can be solved as 4 by 7. Then this would be -3 by 7. Then this would be 2 by 3, -2 by 3 in fact. 0, 0, 1 by 3. 1 by 7, 1 by 7, 0. This is the inverse of A. Yes, this is determinant of A, and this determinant of A. Okay, 1, 1. This is good. You have to go like this. Just ask me whenever you have any doubt. Okay. So we have covered this in a 3 cross 3 determinant. If I want to find out any 3 cross 3 determinant, I will have to first find out. Yeah. See, if I have this determinant A11, A12, A13, A21, A22, A23, A31, A32, A33. This is A33. My bad. So I can expand it along any row or any column. Okay. Expansion का मतलब ये होगा बहुत ही simple, that delta, this value of this determinant, is equals to take any row or any column. So let's say I am taking first row. So I'll take first row and multiply each element with its corresponding cofactor. So A11 का multiplication C11 के साथ, then A12 will get multiplied with C12, A13 with C13. Multiply each component or each element of that row or that column with its cofactor, right, and add all of them. तो देखिए अगर सेकेंड रो के अलॉन्ग एक्सपैंड करना है तो A21 का C21 के साथ मल्टीप्लीकेशन, A22 का C22 के साथ, एंड A23 का C23 के साथ, और फिर ऐड कर दिया सबको. तो टेक एनी रो और एनी कॉलम. लेट्स से मैं फर्स्ट कॉलम के अलॉन्ग एक्सपैंड करना चाहता हूं along this. So I will take these 3 elements and multiply them with their corresponding cofactors. तो A11 लिया, C11 के साथ मल्टीप्लाई किया, A21 लिया, C21 के साथ मल्टीप्लाई किया, A31 लिया, C31 के साथ मल्टीप्लाई किया और ऐड कर दिया. The same thing, the same algorithm we have applied here in this question. मेरे को इसका डिटरमिनेंट चाहिए था. मैंने फर्स्ट रो उठाया मैट्रिक्स का. I took the first row and multiplied each element with its corresponding cofactor. So See, I took 1, 2, 3, the first row, and multiplied 1, 2, 3 by its corresponding cofactors. So multiplied 1 by C11, which is minus 12. देखता जा इधर, ये देख 1 फर्स्ट एलिमेंट लिया, मल्टीप्लाई करा इसके कोफैक्टर के साथ minus 12. सेकंड एलिमेंट लिया 2 था, मल्टीप्लाई किया इसके कोफैक्टर 0 के साथ. थर्ड एलिमेंट 3, मल्टीप्लाई किया इसके कोफैक्टर -3 के साथ. एंड देन फाइंड आउट द वैल्यू. -21 आया. समझ आएगा? Is it clear?
Yes, sir.
Okay, good. And that is how we can find out. Yes, Madhya. We do this to find out whether the given matrix is singular or non-singular. If we see that the matrix is singular, we would not be able to find out the inverse. We would not be able to find out the inverse, but we can still find out the adjoint, right? We don't have any problem with adjoint, but
All right.
inverse we will not be able to find out.
Okay, sir.
Okay, let's solve this one. I'm giving you one problem. Please find out the adjoint and inverse if it exists. And please do it, so solve it quickly. Everyone. I mean, try this. You may be wrong. And if you are stuck in somewhere, then please feel free to ask me. Don't worry. But you would have to practice. Okay, this is -3. Find out its adjoint. Chalo, tum solve karo is baar. You guys, everyone solve it, and I will solve it directly. I'll try to solve it directly. And I'll also check whether I'm correct or not. You guys, everyone solve it quickly. First element should be this. I'm writing out the final answer. So these has to be the cofactors of first row. That is why they are in first column. So your first three answers should be 6, -3, and 8. If you are finding them systematically, I mean. 1, 1, 1, 2, 1, 3, then 2, 1, 2, 2, 2, 3, and then 3, 1, 3, 2, 3, 3. So these are C11, C12, and C13. Are they correct? Can someone confirm them?
Yes, sir.
So
Yes.
I think it's -6, 3, and 8.
Okay.
Sir,
Yes,
so,
Sarah.
I
Yes.
think instead of 8, it's 6.
You are taking the transpose right here.
Yeah. Sorry. Iram, actually, whatever you're telling, this is the cofactor for this. Oh, my bad. Sorry. Whatever you're telling is the cofactor for this. We are finding out the cofactor for this. We are finding, actually, I'm writing the answer directly. So this first column belongs to the cofactor of first row because we have to take the transpose as well. No? So for 3, it should be delete this and delete this. So this should be 0 into -1 minus 4 into -2, which would be +8. And the sign would be positive here. So the sign goes like this: plus, minus, plus, then minus, plus, minus, then again plus, minus, plus. By this time, you should remember these signs, but you haven't practiced for, I guess, determinants enough. So I mean, I'm talking about everyone, not for Iram. There are a lot of students who needs practice. Okay, I'm writing out the cofactors for second row, which would be written in the second column after taking transpose, right? And then check them. This should be 3, yeah. Just give me a thumbs up if someone, if these values are matching with someone.
Yes, sir.
Okay. Cool. Now everybody will start giving me thumbs up. Yeah, we are correct. Are you guys? No, please do it. ये तो सबसे easy option दिया था मैंने. वैसे thumbs up तो कर ही सकते हैं सारे. Yes, correct. Then I'll ask you. After that point, I will ask you how did you calculate this. But first, you complete the mandatory step to give me a thumbs up. No, it's okay, Vadia. I am sure you will be able to find that out. No. Tarif, I think we okay. Okay, let me check once. No, no, this is correct. That is why I told you, see, you will not be able to get it in the first try. You will solve it incorrectly, but that is okay. It's okay. After that point, we'll be able to achieve the right results as well. First, we'll have to go through this pain to find the cofactor for every element. And the last one should be what? -4 + 1 -3.
-3. Yeah.
Yes. This should be the adjoint. And we can easily find out the
Sir, here -6 + 3 is there, right?
-6 + 3. Just give me a minute. No.
Sorry. Correct.
Yes. So to find out the value of determinant, I'm expanding it along the first row. Okay. So this would be 2 into its cofactor, which is 6, plus 1 into the cofactor of 1, which is -3. Guys, we have already taken the transpose. So 1 into -3 plus 3 into the cofactor of 3, which is 8. The value would be 24, 12, 36 minus 3, 33. Value is 33 now. So A inverse exists in this case. And the value for A inverse would be 1 by 33. We can even take this 33 inside. And we can further solve it to get some answer, and that would be the required answer. Okay, B31 as +6. So this, delete this and delete this. Yeah, that is correct. But this will be written here, no? -6. Okay, this is +6, correct. My bad. Austin, you're correct. Good, thank you. This has to be +6. That was the only mistake, I guess. Hopefully. Yes, so we did adjoint, I guess, pretty well. By the end of the class, everyone is trying to get a hold of what is adjoint and how to calculate it. And now I would like to you guys to solve some more questions on this. So let's come to the assignment and find out the. We are not going to the assignments right now. Okay, first of all, so we will go to exercise 4.4. This one. And we will find out the inverse for 4.4. Yes, 4.4. First of all, find out the minor and cofactor wala exercise. So complete this 4.4 as well as 4.5. But for 4.5, you will only have to calculate adjoint. Today, you will only have to calculate adjoint. Adjoint as well as inverse, right? So solve for second. I'm telling you which questions you need to solve. Solve all of these 9 questions. Okay. We'll meet in the tomorrow's class. By the time you should solve these questions to get an understanding of all of the process.